Alright, now we have another problem about buoyancy. Basahin muna natin. A concrete cube 10 inches on each side is to be held in equilibrium underwater by attaching a lightweight foam buoy to it. If the specific weight of concrete and foam are 150 pound per cubic feet and 5 pound per cubic feet respectively, what minimum volume of foam is required? Now, what are we given? We are given a cube na 10 inches daw each side. And then, we are given the specific weight in English units of the concrete cube and the foam buoy na ilalagay natin sa concrete cube natin para ma-hold natin siya in equilibrium underwater. So, let's first write our given. The specific weight of our concrete is 150 pound per cubic feet. And then the specific weight of our, let's just say, foam buoy, FB, ay 5 pound per cubic feet. Alright? That's what we have. And we are looking for what? We are looking for the volume. Hinahanap natin what is the minimum volume of the foam buoy. Of the foam buoy para ma-hold natin siya in equilibrium underwater. So, let's solve this problem. Now, saan tayo magsisimula? Let's first start dun sa mga forces acting on our system. Since it is in water, our block, concrete cube, and the foam buoy has weight. Pareho silang may weight, and weight is always directed downwards. And then, since it has a weight and it is submerged in the fluid will then exert a buoyant force. And mind you that the weight here is the total weight. Meaning, we have the weight of the concrete cube, yung weight ng concrete cube, at saka yung weight ng foam buoy nating ilalagay. So, by simply taking the summation of the vertical forces or the forces in the y direction, we will end up with, we need the total weight. So we need the weight ng concrete plus weight of our foam buoy, and the buoyant force will kokontra siya sa weight natin para nga lumutang at hindi siya lumubog. This is the buoyant force. And they must be equal to 0 again to hold them in equilibrium. Ayan, this is our working equation to solve this problem. Let's just arrange this. Lalabas na ang buoyant force natin ay equal sa weight ng concrete plus weight ng foam buoy. Alright. We are also given na yung cube natin 10 inches on each side. So, better i-convert na natin siya agad para hindi tayo mahirapan. The length of each side is 10 inches. So, 10 inches, let's just divide it by 12 para maging feet. Yan. Or simply 5 over 6. 5 over 6 feet. That is the length of each side ng cube natin. So, we all know that the buoyant force ay equal sa rho GV, in which V here is the volume displaced. Or simply, since rho G is equal to gamma, so we have gamma times the volume displaced. So, itong buoyant force, substitute lang natin doon. And we also know that weight is gamma times the volume of our object. So, substitute lang natin sa variables natin dito in terms of gamma and the volume para mas madali nating ma-analyze yung nawawalang volume ng buoy. From here, our buoyant force is equal to the gamma of the fluid. In this case, this is water. So we have the gamma of H2O times the volume displaced is equal to the weight ng ating concrete, which is specific weight ng concrete times volume ng concrete plus the specific weight naman ng ating foam buoy times the volume of our foam. Ayan. From here, we know that the volume displaced here, since parehong nakalubog yung concrete cube tsaka yung foam buoy, yung volume displaced natin dito is simply yung volume ng concrete tsaka ng foam. So, it's additive. From here, the gamma of H2O times the volume displaced is yung combined volume ng concrete cube tsaka ng foam buoy. So, let's just add the volume of each. This is the volume of the concrete plus the volume of our foam buoy. Foam buoy, ayan. And let's just copy this. Gamma of concrete, volume ng concrete, plus gamma of our foam, and the volume of our foam. Ang nawawala ay yung volume of our foam. V sub FB. So, that's the missing variable. From here, we can substitute. We all know that the gamma of water in English is 62.4 pound per cubic feet. We also have the gamma of concrete. We also have the gamma of our foam buoy. And we all know that the volume of a cube is simply the length of each side. Let's just call this, sige, L na lang. Length of each side. Then you just cube it. Para cubic units siya. Diba? Cubic units. So, we will simply substitute. Sige, lagay natin yung mga units so we could analyze if we have or we can arrive with the correct or proper units. So, what is the gamma of H2O? In English, this is 62.4 pound per cubic feet times the volume of the cube is simply the length of each side, then cube mo lang. Ito, na-convert na natin siya into feet, which is 5/6 feet. So, we will just write it down. 5/6 feet. And this should be Q-cube natin siya. Raised to the third power. Plus the nawawalang volume of our foam buoy. And then, given yung gamma ng concrete cube, which is 150 pound per cubic feet. Let's just write everything down. 150 pound per cubic feet. Again, multiplied by the volume of the cube, which is 5/6 feet cube, plus the gamma of our foam, which is 5 pound per cubic feet, multiplied by the missing variable, the volume of our foam buoy. And as you can see here, mga kasama, we are left with a linear equation with one missing variable, which is the volume of the foam buoy. And if we analyze the units, cancel out lang yung mga feet, cubic feet, and also the pound. Hindi pala, cancel pala yung pound. And we will be left with cubic feet, which is an indication na tama yung ating solution since we have arrived with the correct unit, which is cubic feet. And if you salpak mo lang to sa calcu, this equation, yes, this one, you type that into your calculator and then use the ship solve function, you will arrive with the value of the volume for the foam buoy is let's just round it off to 4 decimal places, 0.8832. That is in cubic feet. And this is our final answer for this problem. This is the minimum volume of foam buoy na kailangan natin para ma-hold natin in equilibrium itong concrete cube natin. That is all for this problem. Our final answer is 0.8832 cubic feet. Alright, as usual,